Okay, so review question 10. Context, or the concepts, is calorimetry, and sort of in variable form. That's what the math is, but the context is that you're preparing for a hike in the Cascades, and you wanted to freeze a bottle of water overnight, so maybe it'll melt by the time you get to the top, but you always have some cold water. And the bottle contains a volume V of water and starts with a temperature Ti. I'm going to assume that that's liquid water. The specific heat of water is Cw, the specific heat of ice is Ci, and the latent heat of fusion is Lf, and the density of water is ρ. Determine an expression for Q, the heat transferred with the water in terms of the given variables as the water cooled to Tf, where Tf is less than 0 degrees. So you basically put it in the freezer. Freezer usually is a few degrees below freezing, so that's what we're doing in this question. So there's 3 stages of what the water has to undergo, so I'll sort of maybe highlight these. So stage 1 first has to cool from T initial to 0 degrees, so we're basically cooling the water down to its freezing point. Stage 2 has to undergo a phase change. From liquid water to ice. So that's 0 degrees to 0 degrees, so there's no temperature change, so that's the piece about the latent heat. So we just undergo a phase change. And then stage 3 needs to cool from 0 degrees to T final while in its solid state. Okay, so there's 3 stages. So there's 3 different, these are 3 different Qs for this particular process. So if you think about Q total, it will be Q1 plus Q2 plus Q3. And in Q1, we would have the mass of the water, C of the water, times the change in temperature. So this final temperature is 0 degrees minus T final. Minus T initial. Sorry about that. The Q2 is an NL term, but in this case, the heat has been removed. So it's a negative. The value of the sign of Q is minus. So we have a minus N times Lf, and then we have a plus mass of the ice times the C of the ice times the final temperature, which is T final, minus the initial temperature of the ice. Now stage 3 is 0 degrees. Okay, so that's what we have here. Now we can describe the mass of the water as its ρ density times its volume, both here and in this, certainly for this particular term. Again, this is the mass of the water too. Now, even though the density of ice is different than the density of liquid water, the mass of the water is not going to change in the bottle. So I'm going to describe this water term as ρ times V, because that would give mass. So even though that the water will expand, so increasing its volume and decreasing the density, the mass of the ice and the mass, whether this is the ice or the water, all stay constant during this process. So I'm going to write this as ρ times V and Cw, 0 degrees minus Ti minus ρ and V. I guess I could have taken out the M terms first before I did all this, but too late now. Ρ times V times Ci Tf minus 0 degrees. So the common term across all is the ρ times V, which is the mass. That's sort of what I'm trying to state, is the mass of the water is staying constant. So I'll take out this row V term, and then we've got the seawater, 0 degrees minus T initial, minus the latent heat of fusion, plus Ci times T final, minus 0 degrees. I'll put in the second parenthesis over here, larger parenthesis. Okay. So what is this going to give us? It's going to give us a negative value for Q. So this will be of course positive. The 0 minus T initial. Assuming the T initial is like something. Maybe I'll give you some bias. It's going to be positive. The parenthesis term here is negative. So this is a negative term. Negative times minus this will be a negative term, and T final is less than 0. So this will also be negative. So if we assume the volume is, I did some calculations earlier. The volume is 700 milliliters, or 700 cubic centimeters, whatever way you want to refer to it as. And let's say the initial temperature is Ti, is, I made this to be at 15 degrees, sort of like temperature of the water comes out of the tap. And let's say the final temperature is negative 5 degrees. Determine the value of Q. Okay, so you want to pause the video and then work out your values, and then you need to look up the latent heat of fusion, the density of water. I find that this value is negative 2.84 by 10 to the 5 joules. So the interpretation of this number, you have two ways you can interpret this. You can say that you can remove you can say that 2.84 by 10 to the 5 joules was removed from the water, or negative 2.84 by 10 to the 5 joules was added. And that sort of seems a little strange, but this Q in a sense is referring to the term energy added. So you can say that negative 2.84 by 10 to the 5 joules was added to the water, or 2.84 by 10 to the 5 joules was removed. So you can sort of think about that as in terms of your bank account. So if you have $200 in your bank account and you were to remove $50, you would, in a sense, you would say that I removed $50. You would not say I removed negative $50, but you could say I added, if there's such a thing, negative $50 to the bank account, such that your net value is 150. So this interpretation is that the removal of 2.84 by 10 to the 5 joules, or the addition of negative 2.84 by 10 to the 5 joules. And this should adhere to this expression. If you're to substitute in the correct values, I believe this is the correct answer that you get.